There are 7 circle theorems that you need to know for GCSE Maths. Now these build upon all the angle rules that you've known for years. Angles on a straight line add up to 180 degrees, base angles of an isosceles triangle are equal, alternate angles are equal, all these different rules. You need to regard these circle theorems as building on top of those. Those simpler rules are still true and they can turn up inside these questions, so don't forget about them. There are 7 circle theorems that you need to know. Some of them are pretty straightforward, others a bit more complicated. In this video we look at the first 3. Let's suppose we have a circle and the diameter is drawn in, splitting the circle into 2 semicircles. If you have that arrangement and that diameter is the side of a triangle where the third corner of the triangle is on the circumference of the circle, what we have is we have a triangle in a semicircle. And this first circle theorem states that the angle in a semicircle is 90 degrees. And I'm going to put that in quotes because that is a statement that you need to learn just as much as you need to know the statement angles in a triangle add up to 180 degrees. You need to know that the angle in a semicircle is 90 degrees. And it doesn't matter where this point is. We could slide this round to a different position. Let's suppose that I chose a different, let's put it there, doesn't really matter. So now I've got a semicircle on the other side. So I've now got an angle in a semicircle over here. That will also be 90 degrees. This point can slide to whichever position you want, taking the triangle with it, and it will always remain 90 degrees. The second circle theorem that you need to know depends upon us understanding some more terminology. This curve here between A and B, this short piece, is known as an arc, A-R-C. This is the arc AB. More precisely, it is known as the minor arc AB. The major arc AB goes all the way around the outside. It's bigger, so it's called the major one. The small one, the more obvious one, is the minor arc AB. And what we're going to do is we're going to draw in a couple of straight lines out to the circumference out there somewhere. And you can see that's produced an angle. Now, the language here is that this angle is subtended by this arc AB, new language. Now, one of the curious things about a circle is that if we draw another pair of lines in, again from AB, but to some other point, maybe like that, then it follows that this angle is identical in size to the first one. Whatever that is the same. And so what we have here is that angles subtended by the same arc are equal. So you need to get used to spotting that pattern. It's quite helpful to put a finger from each hand at the black X, pull them back separately to AB, and then push the fingers back out from AB along the red lines to X. And tracing that out with your fingers gives you a physical way of dealing with it rather than just looking. The third circle theorem in this video relies upon the centre again. That second one didn't rely upon the centre of the circle. We're going to start with quite a similar diagram, but this time we're going to put some lines in there instead. Now, again, if this angle is x, this rule states that this angle is exactly twice as big. And the rule says the angle at the center is twice that at the circumference. So those are the three circle theorems I wanted to look at in this video. But I do just want to highlight the fact that these last two, they sometimes look quite different, even though they are the same rule. So I'm just going to draw them again. Now, if I draw in a more complicated shape, let's put a quadrilateral in. Let's draw in some lines here. Because of the extra lines, it is not so clear that some of this is going on as well. But if we look at it, we can see if we take this angle here. So I'm starting at this point, I pull my finger back along this line, and I get down to here as I pull back from angle X. And then, as I push back out from these 2 points in a different direction, I get up to here. And so this is angle X as well. But if instead I started in a different place, let's suppose I started here, different angle Y, this time pulling my fingers back along these lines gets me back to here and to here. And now if I push out from those, I get out to here. And so these two angles match each other. So it's the same rule each time, angles subtended by the same arc are equal, but it feels more complicated. We have the same sort of issue with this rule, the angle at the center being twice that at the circumference. The arrowhead is quite distinctive. But watch what happens if we use the idea that these two angles are the same as each other. That means that this angle here, this point here, it can it can go round, it can slide round, and we could get something that looks like this. And so if this is X, then this is 2x. It takes a bit of thinking about, but practice does make perfect. Learn these three rules and how to apply them.